Hi, Sierra.
Hello.
Hi, Adriana.
Good morning.
Okay, sorry I'm a little bit late. Hi, Nicole. Okay, so I'm going to go ahead and get started. So today we're going to go over homework 8. I've got a little short outline to go over with you guys that will help you with homework 8. And it'll help you kind of see how we're going to use some of the same testing, inferential testing, to do some reliability testing. So it's going to be very similar types of analysis, but instead of just looking for differences, we're going to be using that to actually test to see. We're going to be looking for no differences, and I'll be explaining that. So I've got a little outline to kind of go over that with you, and then I'm going to go over homework 8. So that's what we're going to do today. And it's going to kind of show you how we can use t-tests to actually test the reliability of different measurements that we might be doing in our fields. Okay, so that's kind of what we're going to be doing today. I want to let you know that homework 7 and quiz 7 over the lecture we just finished yesterday, I made that due by the end of the day on Thursday. So they both are open right now. Please prepare before you get on there, okay? Because these are challenging, you know, homework 6, quiz 6, homework 7, quiz 7, and homework 8, quiz 8. These are the most challenging assessments in the class. So make sure you're doing the practice homework. Make sure you're getting on there and reviewing the lectures, watching the extra videos I gave you. You really got to prepare before you get on and do quiz 7, lecture 7, homework 7, and then quiz 8 and homework 8, because they are challenging, okay? I did also post an extra credit for the midterm. So I had mentioned this earlier, but if you want 2 additional points for your midterm, you can go on to Blackboard, and you will see under quizzes and exams, you'll see an extra credit for the midterm. And what you have to do for this is I give you all the midterm scores. So I give you the scores that were scored on the midterm for this session. And you'll take those scores, put them into Excel, and then do descriptive statistics on them. So you'll get all the descriptive statistics, mean, median, mode, standard deviation. Then you would, and you'll be reporting those. That's part of the extra credit. So the first thing I ask for is what's the mean, median, mode of the distribution. Then I ask you to take your score and figure out your z-score. So what is your z-score? And then tell me what percentile you fell at. So you'll take your z-score, you'll put it onto, you'll look at your z-score on the z-table, and you'll tell me what your percentile is. And then you'll also tell me what is the confidence interval for 95%. So you'll take the mean, you'll add the standard deviation twice, you subtract the standard deviation twice to tell me what the range is, the confidence interval for 95%, and then an example of a score that would fall outside of that. Okay, so if you do those, if you answer those questions and you get them all right, you can get up to 2 extra points on your midterm. Okay, so that's gonna, I think I made that due by the end of the weekend. So you could do that whenever, by the end of the day on Sunday. Okay. Okay, so I think that's all I need to let you know before we get started. So if you don't have your camera on, I would love for you to have your camera on because it's really hard for me to so Nicole, Sierra, thanks for having your camera on. So if you don't have your video on, I would really appreciate that because it helps me to be able to see your faces. Okay, so I'm going to go ahead and get started with the short kind of mini lecture that I have for how we might use analysis to test the validity of a measurement. Okay, so I'm going to go ahead and share screen with that lecture. Okay, so for this lecture, what we're going to be doing is we're going to be talking about how we can use inferential testing in order to determine whether a measurement is correct or not, okay? So if you'll remember, we talked about norm reference and criterion referenced, okay? So a norm reference test would compare or refer individual scores to an average sample population, okay? So sample or population. So this is where we would compare individual scores to an average of another group, either a sample or a population. So we would be comparing against the norm. Criterion's reference testing, or when we compare individual scores to an external standard. So what's the standard we want people to meet? Okay, so this is one way that we would use data collection or measurement to give people feedback, to give them reference and feedback. So if you remember back all the way back to lecture 1, we talked about one of the reasons we would do measurement is to give people feedback or to place them. And so these are 2 ways that we can do this. So we could do some testing or collect data to give people some reference for where they fall within a group. So this could be in health, this could be in sport, this could be in rehab, this could be in just a lot of different aspects. We can also do the same for criterion reference. So this would be setting a specific criteria. This is also very common in health or in public health, where we say, you know, you need to have like less than an A1C of 7, or you want to keep your cholesterol, you know, below 180, or you know, you want to have muscle mass above this level. So there's, or we want to have a specific time for something physical, like some kind of performance. So we would use criterion referenced, okay? So we can actually use distributions to give people kind of some referencing. So, you know, this has happened to you, like maybe you took the SAT or the ACT and you were able to see on your results what your score was, but they also let you know what your percentile was. So that kind of gave you a feel for how you compared against the other group that took the SAT or the ACT that year. Okay, so it gives you an idea about the distribution. This also happens a lot with medical testing. It happens with psychological testing a lot. It happens with placing people for classes intellectually. It helps with actually determining if people are best fit for certain jobs. So we use this kind of referencing a lot, okay? And how people fall in the distribution. Okay, so when we're looking at test referencing, we can collect information in a population that can then give us we can either do for the population or we can collect a sample. And this gives us an idea about how we can create referencing, group referencing. Okay, so if I were to, exactly what you're going to do for the extra credit is what you would do for referencing. Okay, so you're going to be able to see where did you fall on this norm referencing. So all we're using is a norm reference for the class. So you're getting your, we're figuring out what the norm is. So what was the median, the mean of the midterm. So what was the mean? Then you might look at what was the percentile? Where did people fall? Where did they fall in that distribution? Okay, so we can do that as norm referencing. The other thing we could do is, like for the midterm, we could criterion reference that by saying, you know, if you got 90% of the points or more, you would get an A. If you got 80% or more, you would get a B. So that's the criterion reference. Okay, so we can set criteria based on a certain percentage of the points that are expected for a certain grade. So in this class, you're actually getting both, okay? You're gonna get a norm, so you're gonna be able to say, did I fall in the 16th percentile or did I fall in the 80th percentile? You know, you're just gonna be able to see where you fell in the percentile for just that one measure. So remember, that one measure isn't your total grade in the class, but that for just that one measure. But then the criteria in this class, I don't norm reference. So I don't grade on a curve in this class. I grade on a criterion. Okay, so you would have to earn 90% or better of the possible weighted points in order for you to get an A in this class. Okay, that's a criterion. So there's a laid out criterion. You must get 90% of the points or more in order to get an A, 80% or points or more in order to get a B, 70% or more to get a C, okay? And in this class, you must get, you know, you need to get a C because that's what's required for the major. So that's the goal. And those are criterion, okay? So that would be a criterion. Okay, the other thing, and this is where we're going to spend the majority of our time today on the homework, is determining how reliable a test is, okay? So if I'm doing a test, I want to make sure that it's reliable, that I'll get the same results every time. I also can try to test whether I can get reliable results from a test that's not as difficult or expensive to do, okay? So I can look at, say for instance, we've talked about this before, I could look at either I could do body fat with a very expensive, difficult MRI test that gives us a really very valid measure of body fat, but that's really expensive. I'm not going to be able to do that on a bunch of people. So instead, I could do skin fold analysis. Okay, but how reliable are skin folds, right? Do they give me similar results that an MRI would give me? So I can actually do a comparison between the MRI and the skin fold, right? And I don't really want them to be different. I want them to give me results that are not statistically different, okay? Because if they're not different, then I could use the skin folds instead of the MRI because it's way cheaper. Okay. But if I have the MRI and I have the skin folds and I do a t-test on the results and I find out that those results are statistically significantly different, then I have got a problem using skin folds, because what that's telling me is that they're not as good at measuring as the gold standard MRI is. Okay, so this just gives us an idea of how can I be confident in that skin fold test. Okay, can I be confident in a test that isn't as hard to do? Okay, so something like a skin fold can give me an idea of what body fat is, but does it have enough commonality with the MRI that I feel confident to use it? Okay, so I can have a gold standard test, like I could test, for instance, I could test depression, and there are some gold standard tests, but they're over 100 questions long, and they also involve an interview. Well, when you're doing mass testing to screen for people that might be depressed, you don't really have the time, and you may not have the ability to do the gold standard depression test. So there have been some depression tests that have been developed that are like 10 items. And what they did was they continually compared them against the gold standard, and they continually was able to reduce the questions down and down and down until they could say, this 10 item depression inventory is as reliable as this very difficult 100 question and interview assessment. Okay, and that was all done with test retest reliability. Okay, so that's what we're going to be doing today. We're going to be looking at a gold standard, and we're going to compare that against a test that is easier to do and cheaper to do. And we're going to see if we feel confident that that's reliable enough. Okay, so the way we're going to do that is, first, we're going to see, are the outcomes significantly different? So we're going to use a t-test to see if they're significantly different, which we don't want them to be different because we want the easier, cheaper one to be as reliable as the gold standard. Okay, if they were different, we wouldn't want to use the easier and cheaper one. We wouldn't feel as confident with it. The other thing we're going to use is correlation, because if they have a high correlation, that means that we can feel confident that the easier, cheaper method is very related to the gold standard. So we're going to be doing both of those. We're going to be looking for a very high correlation, above 0.7, 0.8. And then we're also going to be looking at no significant difference between the scores. Okay, so does that make sense to you guys? It's a little bit different way of using these inferential tests to help us make a decision. Okay, so yesterday and so on Monday and Tuesday, we were talking about using t-tests and ANOVAs to see if there was a difference between two groups. Okay, so like if we were doing experimental research and we were using a independent variable and we were manipulating that, one group got it, one group didn't. We wanted to see a difference because we wanted to see that the experimental group actually, that independent variable made a difference, and that difference could be measured by seeing that there was a difference at post between the two groups. Okay, so we were using it that way. We were saying, oh, well, after we did this education, we could see that knowledge improved, or we could see that weight decreased, or whatever we were measuring, whatever our dependent variable was. So we would want to see a significant difference. We'd want to see a p-value below 0.05. We'd want to see our calculated statistic be higher than our critical statistic, or our critical statistic be lower than our calculated statistic, okay? But in this case, we actually don't want to see a difference, okay? And we want to see a high correlation. Okay, so that's how we're going to see with retest reliability. We're going to calculate the Spearman R to see if there's a correlation, right? And then we're going to try to see also if that they're not different, that you can actually look and see if there's that test reliability. Okay. And then there's also some information on criterion, content, and construct validity. I'm not going to be testing you on that, but if you were going to be actually developing assessments or surveys, you would be doing some test validity on that, but I'm not going to be testing you on that. We're going to be focusing today on determining the reliability. Okay? So is everybody feeling fairly confident about that you understand what we're talking about? Okay, so we've got the gold standard, more difficult, longer, costs more, probably more valid though, right? More valid, less error. Okay, so like doing the MRI or doing the really long depression inventory, less error, but difficult to do. Wouldn't be able to do it with large groups of people. So instead, we want to develop some easier methodology, okay? So we want to develop a 10-item depression inventory, or we want to develop something easier to collect skin folds. Collect body fat, like the skin fold analysis, okay? Skin fold test. So, but we want to make sure that those two tests are equivalent, that I'm getting good enough results that I can feel confident in using the easier test, okay, to collect the information. So I would look for a really high correlation over 0.7 or 0.8, okay? And I would look for no difference on a t-test because I want them to be the same. I want to be able to say statistically, these results are no different, okay? Okay, and that's in comparison to what we did yesterday and on Monday, where we were looking to see if an independent variable actually did make a difference. We were looking for differences, okay? And if there was no difference, then we would say, this experimental independent variable really didn't make a difference. It's probably not worth doing, okay? So if there's no questions about the lecture, then I'm gonna pop into the practice homework. Okay, so this is practice homework 8, which is under module 3, I believe. No, it's actually under module 4. Okay, so it's actually under module 4. So when you go to get it, it'll be under module 4. Okay, so practice homework 8. Okay, so what's happening with practice homework 8? Let me share a screen for that so you guys can see it. You can actually bring it up on your, if you wanted to, you could bring it up on your Blackboard, but you may not be able to do that. You may not have 2 screens. It might be difficult. So let me share practice homework 8 with you. Okay, so what we're looking at in practice homework 8, can you guys see practice homework 8 right here? Okay, so what we're looking in practice homework 8, I'm going to give you 2 data sets, okay? The first of the two sets is scores from a Wingate power test. Okay, so what the Wingate power test does is it measures your peak power. This is like a running test. It measures your peak power, it measures your mean power, and it measures your fatigue index. Okay, so the peak power is after 5 seconds of sprinting, the mean power is 30 seconds, and then the fatigue index is how much reduction does the person have in power from peak till the end of the test. Okay, so how fast did the person fatigue? Okay, so you've got this data. I'm going to be pulling it up here in a second. So you've got these 3 sets of data: the peak power, the mean power, and the fatigue index. Okay, so what we're going to be doing is performing paired sample t-tests on each of the 3 variables to evaluate the reliability of the test in respect to each variable. Okay, so we're going to look for correlation, the paired sample t-test p-values. We're going to say what variables are tested with high reliability based on that correlation, and we want a high correlation. So I'm asking you today that the correlation would be over 0.9 and that there would be no significant difference in a two-tailed test. We'll see no difference either side, no difference on the negative side or the positive side, so we'll be doing a two-tailed test, okay? And then we'll talk about what factors we might want to control, okay? The next set of data, I'm giving you 2 sets of VO2 max measurements, one from a submax protocol, okay, and one from the maximal protocol. So the maximal protocol is harder to do, okay, much harder to do a maximal protocol on the treadmill. So I'm going to compare that with an easier protocol, the submax protocol, okay, and then in that, we're going to be using these to figure out whether the submax protocol is as good as the gold standard, the max protocol. Okay, so we'll be looking at the correlation between the 2 tests. Again, the p-value in the t-test, and we'll be looking at the correlation and that the significance in the two-tailed tests. We want non-significance. Remember, we don't want it to be different. And then again, we'll look at what factors we would want to control to influence the validity of the test. Okay, so when we're looking at reliability data, we're going to look at the Wingate. Okay, those 3 measures. We're going to do a test retest on it using the dependent t-test because we have 1 group, 2 measures, okay? And then the second analysis we're going to do for the validity test is that comparison of the gold standard against the substandard test, okay? So that's what we're doing today. So let me go in and pull up the data set. Okay, so in the data set, okay, so can you guys see the data set now? Okay, so in the data set, what we have is we have for the test retest, okay? So remember, the test retest is testing reliability. It's trying to see, is there no difference between the pre-tests and it's not really a pre-test and a post-test, but we're doing the test 2 times. And we're trying to see on 2 different days, and we're trying to see, did we get the same results? So we would do all these tests on day 1, and then maybe a day later, we would do the tests again. We just want to see, do we get the same results? Okay, do we get the same results? Are these reliable tests? Can we be sure that the results that we get are reliable? Like we're going to get those same results every time. Okay, if the results wildly vary just the next day, that might tell you that this test isn't really, reliable. We can't get the same results over and over again. Okay, so we're going to use what's called test retest on that. Okay, so what we do is we've got the peak, mean, fatigue that we did say on Monday with a group of athletes. Okay, then we're going to do this test right again the next day, and we're going to see, do we get similar results? We could do this on the depression inventory too. So let's say we have a depression inventory and we do it today. We measure someone's depression, and then we do it again tomorrow. Well, depression shouldn't vary wildly in one day, right? Especially if you're looking at somebody that might have like major depression. So we want to see, does it give us the same results? Or is it very different? Did it say they had major depression one day and the next day it said they were fine? Okay, well, maybe this isn't a very good measure of depression. So that's why we're doing the test retest. Okay, so we've got these tests. So what we're going to do is we're going to do t-tests between each one. So we're going to do a t-test between measure 1 on peak power compared to measure 2 on peak power. So remember, this is one group of athletes. We measured peak power one day, then we measured peak power the next day, and we're going to see, do we get generally the same results? Okay, so the way we would do that is to run a t-test. Okay, so remember, the way to run a t-test, we're going to go to our data. We're going to go to our data analysis. We want to do a t-test. So we go down to t-test. Remember, this is a within or a dependent t-test. So it's a paired t-test because it's one group, two measures. Okay, one group, two measures. So for test retest, reliability tests, you're always going to use a paired t-test because it's always going to be one group that they've measured more than once, 2 times. And we're going to see what's going on with that. Okay, so we're going to do a paired t-test. Okay, so our variable range 1 is going to be our day 1 peak power measures. So we're going to pull those. Our variable range 2 is going to be our day 2 peak power measure. Okay, I left the labels in. Okay, you tell it where you want to put it, and then you would hit OK. Okay, so here's what that first one looks like. The peak power, the mean for the peak power at the first day was 450. The mean for the peak power the second day was 440. Okay, so we had said we wanted to do a two-tailed test because we want to see if there's a difference on either side. Was there a major decrease or was there a major increase? Remember, we don't want to see a change if we want to say this is a reliable test. So we'd hop down to our two-tailed test. Okay, so our calculated t-stat is 0.69. Okay, our calculated t-stat is 0.69. Our critical two-tailed T is 2.07. Okay, so is our calculated larger than our critical? Is our critical smaller than our calculated? Yeah, so that tells us there's no difference. We can follow that up by looking at the probability value. Our probability value is 0.49, 49%. Is that less than 5% or 0.05? No. So this tells us there's no difference between these mean values. So that means we can say that's reliable. Okay, it's reliable because we got basically the same measure on day 1 and day 2. There was no statistical difference between those two measures. So that's telling us that it's reliable. okay? So as I'm testing it one day and then the very next day, there's no difference, that's a reliable test. If there would have been a difference, then I would have said like, maybe it's not so reliable. Okay, now don't get me wrong. If we were doing an experimental project, we could do an experimental project and we could say, pull a random sampling of 60 people, 30 people to a control group, 30 people to an experimental group. The experimental group gets sprint training. The control group does not, okay? We measure at pre the Wingate test with all of these measures. We measure at post the Wingate test with all of these measures, okay? So in the experimental group, the group that got the sprint training, we would hope we saw an increase in peak power from pre to post, right? If we measured pre, then we trained them for 12 weeks, then we measured post, we would probably see an increase in peak power. And that would say, and then maybe in the control group, there's no increase in peak power. So then what that's telling us is, oh, our sprint training created or caused an increase in peak power over the 12 weeks. Okay, so we would hope to see a difference if we want to see if that training made a difference to increase their peak power. But in this case, we're using this just to see if from one day to the next, does this Wingate test really do a good job, a reliable job of giving us the same measure over and over again? So is it reliable? Okay, so in this case, voila, peak power was not different. Okay, the T critical was higher than the T stat. The 0.05 was, the probability was higher than 0.05, so there's no difference. Test is reliable. Okay, then we're going to do the same thing for the other two. Go to data analysis. We're going to do a paired t-test. We're going to grab, the mean power next. So we'd grab the mean power pre, then we would grab the mean power post. We would tell it where to put it on our on our page, hit OK. And then here's the output of the mean power. So here's the output of the mean power. The mean was 359 for the first measurement. The mean was 374 for the second measurement. So two-tail test again. We want to see if there's a difference either way. We hop down here. We look at the t-stat. The t-stat was 1.63, okay? The t-critical was 2.07. Okay, that's higher than our calculated T. Okay, we look at our probability value. It's 0.11. That's larger than 0.05. So we know there's no difference. Okay, because for there to be a difference, this would have been below 0.05. This would have been less than the calculated T. Okay, the critical is less than the calculated, or the calculated is more than the critical. Okay, so we know that there's no statistical difference here. So that part is also reliable. So the mean power was reliable. Okay, then we do the same thing for the last group. Data analysis, we're still using that paired two sample, one group, two measures. We're going to pull fatigue index. This is how much they fatigued from the one day. Fatigued from the beginning to the end of the test. Whoops, just messed that up. Okay, you've always got to be careful that you're pulling the right data. Okay, so my day one data is here. My day two data, make sure I get it into the variable 2. I've got my labels, tell it where to put it, hit OK. Okay, so my output here for my fatigue index, okay? So again, using a two-tail test, see if there's a difference on either side, hop down to two-tail test, look at my calculated T. 0.87. Look at my T critical, 2.07. Okay, so that is higher than my calculated. My calculated's lower than my critical. I go to my probability, 0.39. That's not smaller than 0.05. That's larger than 0.05. 39% is larger than 0.05 or 5%. There's no difference in fatigue index. Okay, no statistical difference between day 1 and day 2. Okay, so we can say this is also reliable. So from this outcome, the Wingate test is a reliable test. It reliably gives you the same results from day 1 to day 2. Okay, we can feel good about its reliability. Okay, make sense? Okay. Questions about that? Questions, comments? So that's reliability, test, retest. Okay. So now we're going to see on our next, well, so then I guess we could go back and we could answer the questions to the homework. Okay. Oh, we were also going to do I forgot, we were also going to do a correlation on this to see how correlated they were. I guess I didn't run that. Okay, so we could do a correlation on this also. Okay, so if we're going to do a correlation, we've got to, remember, we've got to put our data right next to each other to do a correlation. Okay? Let me see, did I actually ask you to do correlation on that? Okay, yeah, we are going to do a correlation on that. So let me go back to our data and let's do a correlation. I thought I ran all of these. Okay, so if I want to do a correlation, they need to be right next to each other. So I could pull a correlation for this whole entire thing, or I could do correlations just between the two variables. Okay, I'm going to go ahead and just run a correlation on the whole entire thing. Okay, so I'm going to do a correlation, and I'm going to pull the whole entire data set. Okay, it's in columns. I've got my labels in the first row. Okay, and I actually want to put this, let me put this in H1. Okay, so what we're going to do is we're going to look for, so we've got all of our variables here. We've got the peak power the first time and the peak power the second time. Okay, so let's look at the peak power the first time against the peak power the second time. Okay, so are you guys seeing how to read that? We read it just like a map. We look at the peak power for day 1 against peak power day 2, which is down here. So we've got a correlation of 0.93. Okay, you guys seeing that? Peak power, this is the first peak power. So this is the second peak power. They've got a correlation of 0.93. Okay, so that's a good high correlation. That's good. Okay, then we could look at mean power. Okay, so here's mean power, the first one, against the mean power, the second one, right there, 0.95. That's nice and high. That's good. We know that there's a good high correlation there. Okay, then we're going to look at fatigue index against fatigue index. Okay, that's 0.37. What do you guys think about that one? Yeah, it's not so good. That would affect my confidence in the reliability. It's not, even though there wasn't a significant difference, I would have some question about the reliability in the fatigue index because the correlation was so low. Okay, so we would want to see that above 0.7, 0.8. Okay, so in my report, I would definitely say, even though there was no statistical difference between the time 1 and time 2 measures, I'm questioning the reliability based on the correlation. Okay, so if we go back to the homework, let's go back to the homework and look at that and answer the questions then. So if we go back to the homework, and it asks, what is the correlation for each variable comparison? Okay, well, so from peak power to peak power, we saw the 0.93. From mean power to mean power, we saw the 0.96. And for fatigue index to fatigue index, we saw the 0.37. Okay. Then we looked at those paired or dependent t-test values. We did measure one, day 1 against day 2 for each of the variables. Okay, so if we looked at the p-value for the peak power, it was 0.49, which is not below 0.05. Then we saw the mean power probability was 0.12, so not below 0.05, and the fatigue index was 0.39 on the probability, okay, not below 0.05. So none of these p-values were significant. There was no significant difference. So we already found that out, right? We ran all of those t-tests. We found out there's no significant difference in these probability levels. They would have needed to be below 0.05, smaller than 0.05, okay? So we can feel really confident about peak power and mean power, because peak power, no significant difference and high correlation. Mean power, no significant difference, high correlation. Fatigue index, no significant no significant difference, but crummy correlation. So we're not saying this is as good on reliability. Okay, so it's really got to have both for us to feel confident. Okay, we can say, yeah, it probably has some reliability, but without the high correlation, you kind of question it. You'd want to do more research. Okay, the other things that could affect this outcome, error. Remember, there's error everywhere. So the other things that could affect the outcomes, when was the wind gate done? Okay, so you'd want to do it both at the same time of day, because like heat could affect your ability to sprint. So I would say you would want to do these both in the morning if you're doing them outside, or you'd want to do them in a controlled environment. Some people have more energy, or they're at their highest peak energy in the morning. Some people are at a higher peak energy in early afternoon. So we'd have to measure this at the same time of the day, the first day and the second day. We'd have to use the exact same methodology. The person collecting the data, we'd want the same person. We'd want someone skilled that knew what they were doing. Make sure that the bikes or the treadmill or the surface that you were doing that sprint test on was calibrated properly. Temperatures were the same. You know, make sure that the athletes hadn't pulled all-nighters the night before or partied or something. That could affect it. So there's all kinds of things that can affect your data. You know, like, did I do a depression inventory and then there was some tragedy that happened before I did it the second time? Could that affect people's outlook? Absolutely, right? That could create error. You know, so I would want to make sure I was aware of any kind of confounding variables. Okay, so that's the first one. Test, retest reliability. Okay, the second one, we're looking at the reliability and validity of a max versus a submax, or a gold standard versus an easier test. Does it give us the same outcomes? And can we be confident about it? Okay, so is it, are we getting reliable outcomes, and can we feel confident about the validity of the test? Is it the same as the gold standard? Okay, so what we're going to be looking at is correlation, and then we're also going to do a t-test. Okay, we're also doing a t-test, also dependent, because it's going to be one group. We're going to be doing the gold standard on them, and we're going to be doing the substandard test on them. So it's still one group, two measures. So we're still doing the dependent t-test. Okay, so let's go back to our Excel spreadsheet. Okay, so we're back at the spreadsheet. We go down now. I've got some VO2 data. Okay, so I've got some submax testing, and I've got the gold standard VO2 max testing. Okay, so this is their true max, gold standard, and this is their submax. A different test that's easier to do and not as expensive. Okay, so the first thing we want to do is do a correlation. Okay, so we want to go ahead and correlate those. I guess I just forgot to do the correlations. Okay, so we'll do the correlations. So my input range here, I'm going to input the VO2 max data. I'm going to get rid of these because I want to get my I want to put the sub max and the true max here. Okay. Okay, so let me go back in correlation. I'm going to get all my data. I've got my labels in the front row. Okay, I'm going to put this data, let's see, let me get it down here. Let me put it actually in H12. Okay, in columns, okay. So here's my correlation, okay? So I've got my submax against my true max. I've got a correlation of 0.45, okay? Not so great, okay? Now I'm going to do the t-test. Okay, so data analysis. I'm going to go down and get my paired t-test. Remember, I'm doing the paired t-test because I've got one group, two measures, the max and the submax. Okay. Okay, so for my variable 1, I'm going to be grabbing my submax. For my variable 2, I'm going to be grabbing my true max. I've got my labels in the first row. I tell it where to put it, and then I would hit OK. I've already ran that one. Okay, so here's my output for my two variables. Okay, my true max and my submax. So I can see my means, 48.7 and 40.8 or 40.9. Okay, now, same thing. I want to say I'm hypothesizing there's no difference. Okay, so I'm going to look at a two-tailed test. I want to see if there's a difference on either side. So I'd hop down to my two-tailed test. Okay, I look at my t-stat. My calculated t is 1.78. Okay, it is smaller than my t-critical. Okay, then I double check against my probability. My probability is 0.108. That is not smaller than 0.05. 10% is not smaller than 5%. Okay, my t-critical in this case is not smaller than my calculated. Okay, so there's no difference here. No difference from my true max, my gold standard, and my submax. Okay, so we didn't find a difference here, which is good news, but what did we find on the correlation? Not good. I asked you to get a 0.9 or above. Okay, did not reach that. Okay, probability value was only 0.108 or 0.109. So there wasn't a difference, which was good, but correlation not good enough. It didn't meet both criteria. Okay, so if we hop back to the homework, what did I do with my homework? There it is. Okay, if we hop back into the homework and we ask, what is so this is our validity reliability measurement. What is the correlation between the tests? Okay, we come down here, the correlation was 0.45. Okay, and then what was the t-test p-value? 0.10. Okay, so what are, is the submax protocol a valid, and if it's valid, it's also reliable, a valid and reliable test exceeding 0.9 and a non-significant two-tailed test? Well, the test is not very valid. Although the p-value is not significant, the correlation is moderate to weak. Okay, so the test is different than the gold standard. It's not as good. Okay, and again, the same types of things. We could still have confounding variables that could have created error in this. So what was the methodology used? What was the skill? What was the calibration, temperature, fatigue level? There's all different kinds of variables that could enter in that could cause error in our outcomes. Okay. Questions about that? Okay, so just a different way to use those inferential tests, the correlation and the t-tests. Okay, so any questions about any of this? Correlations, correlations are relationships, and regression is prediction equations, y equals mx plus b, okay? T-tests are looking for differences, okay? Remember, Correlation and regression is primarily used with descriptive research. It helps you come up with more questions or do some predictions, okay? T-tests and ANOVAs are primarily used with experimental research. It's looking for differences. Okay, T-tests are two groups with one measure. That would be an independent T-test, or one group with two measures would be a dependent T-test. The independent T-test is a between measure between two groups, okay, two samples. The dependent T-test is a within one group, two measures. Okay, those measures are paired. Okay, we're looking for differences. This would see, did my independent variable actually make the difference? Okay, that's what we're testing for. Okay, if there's no difference, then I would say, that independent variable really didn't make a difference. Okay, it's not effective, or it's not something that I would want to spend time or energy on. Okay, the ANOVA, and in t-test, the inferential statistic is the t value. Okay, and so we're getting a t value. We're comparing that against a critical t, okay, to develop a probability level. The probability level needs to be below 0.05, since we're using the 95% significance level and the 0.05 alpha level. So it needs to be below 0.05 for there to say there's a difference between those two groups. Okay. And if we say there's no difference anywhere, null hypothesis, we would use a two-tailed test. If we're using an alternative or directional hypothesis, where we're thinking that it's going to increase a score or significantly decrease a score, then we would use a one-tailed test. Okay. ANOVA is done with 3 or more groups. Okay, 3 or more groups. It develops an F ratio. That's the inferential statistic. Okay, that F ratio would be compared to a critical F. Okay, in order for there to be a difference, the F ratio, the F statistic should be higher than the critical F. Or if it's easier for you to think about it, the critical F should be lower than the measured F ratio. Okay, the calculated F ratio. And the p-value still has to be below 0.05. Okay, in order for us to say there's a difference. If there actually is a difference in ANOVA, we don't know exactly where the difference is between those 3 or more groups. So if there is a difference, we would need to run a post hoc test. And in the post hoc tests, we will be able to see how big the differences have to be in order for each sample for us to be able to say they're different, each group. Okay? So for this class, we're going to use the Tukey HSD on a significant difference. I will be giving you that difference, and then all you have to do is subtract the group means from each other in order to see if that difference is at or above the Tukey HSD. Is it a larger difference than the Tukey HSD minimum? If it is, that means those two groups are different. So if you had 3 groups, you would subtract 1 and 2 from each other, 2 and 3 from each other, and 1 and 3 from each other to see where the differences lie. Okay, you wouldn't need to perform a post hoc test if there was no statistical difference on the ANOVA. There's no reason to. Okay. Okay, and then today we looked at reliability and validity. Reliability being test-retest reliability, where we would take a tool, a test, and we would give it to the population 2 or more times. Okay, in this case, we're just doing 2. And we would want to see, is there a difference between the times that I gave it to them? Like another really good example would be like a scale. If we want to see if a scale is reliable, I could weigh somebody, then I could weigh them again, then I could weigh them again, then I could weigh them again. Okay. And then I could, since I have more than 2 measurements, I had 4 measurements, what kind of test would I need to do? Instead of the t-test, what would I do?
Would that be an ANOVA?
Yeah, so then I would run an ANOVA if I had more than 2 groups. And I would, and if I want that scale to be reliable, Sierra, would I want to see a significant difference in that ANOVA? No, you wouldn't want to see a difference. You'd want to see that all 4 of those measurements are close enough that we can say this scale gives us a reliable measurement. It gives us the same measurement every time. And you guys know scales differ a little bit. If you have a digital scale and you get on, it might differ by, you know, 1/10 of a pound here and there. But what if what if you had a scale where somebody got on and it was like 130, and then it was like 134, and then it was like 125, and then it was 128? You might see some difference. That's not very reliable, right? Then you'd say, oh, that's not a reliable instrument. It's not giving us the same measure over and over and over again, okay? So we would want to compare those either with the t-test if I only have 2 measures. If I had 3 or more measures, I would use an ANOVA. And I wouldn't want to see a difference, okay, to say it's reliable. So that's test, retest reliability, okay? For the validity and reliability of a gold standard against a not as good, probably because it's easier, it doesn't cost as much, it's not as in-depth test. So we've got a gold standard and a substandard test. We want to see, do those correlate highly? And if we did a t-test between the gold standard and the substandard, are there no significant differences? Okay, so we're going to always look at correlation too, because we want high correlation between the scores. That's the same with the test retest reliability too. We want those correlations. We want them to be highly related and not different. Okay, so we do the same thing for validity. Does that substandard, does it measure the same thing in a reliable way as the gold standard does? So we would do a correlation. We'd want a high correlation, 0.8, 0.9. And then we would want to look at the t-test, the dependent t-test, to see there was no difference between the outcomes. Okay, so that is a validity measurement. Okay, so questions, any questions? Okay, so I highly encourage you, before you do homework 7 or homework 8, before you do quiz 7 or quiz 8, that you go back and you review, do the practice homework, reread, watch the videos, so you feel confident about your knowledge in these. Okay? If you're still struggling with how to tell whether something is significantly different, go back, ask me questions, go back and review, write stuff down, okay? That's how you learn. You learn by repetition, you learn by writing things down, you learn by watching, you learn by listening, you learn by actually engaging, by doing the homework, okay? So if you just hear my voice, that's one thing, but you've got to actually read it, rewrite it, do the problems. That's the only way to really get good understanding, okay? Okay. So homework 8 and quiz 8 will be due by the end of the day on Sunday. Okay. So quiz 7, homework 7 due by the end of the day tomorrow. Homework 8, quiz 8, which is on this reliability and validity stuff, by the end of the day on Sunday. Okay, so I'll get those open. So if you are able to do the work and get prepared, you can get them done on your timeline. Okay, so I want to encourage you guys, don't get distracted. It's really easy. I know that there's a lot going on, but we're down to the wire. Okay, we've got one more day this week, and then we've got our classes next week. So we've got to stay focused, okay? The other thing is I want to make sure you've sent your link out. Okay, we've got 18 responses. I really want like 80, 80, 90, okay? So make sure that you're sending that out, doing reminders, okay? We need to get feedback. We need to get people filling that survey out. It's only a 3-minute survey. Okay, SurveyMonkey said on average it would take someone 3 minutes to fill out. So let's try to get people to fill that out, okay? Tomorrow we're going to be focusing on how to write the report, what the expectations are, what you might be doing this weekend to get prepared to get your report out. Okay, next week that's all we're going to be focusing on is the project. Okay, I'm also going to get the final ready. That way, since you're going to be done with all your quizzes and all the material, I'm going to get the final ready so you guys can go ahead and take the final whenever it's good for you. I know for some people, they'd like to just get the final done. You know, they'd like to just get that assessment done. So I'm going to get it ready to go. But I will do a little review session next week, or I'll put one out. I'll put something written out. My in-person review session wasn't very well attended. But I'll put a little little thing out probably in class. I'll do a review of the items that were really missed on the midterm. I think we need to do that because you're going to see those again on the final. Okay, because again, repetition, that's the way we learn. If you get something wrong, you need another shot at it. Okay, so you'll get another shot at the ones that were most highly missed on the midterm. And I will take some class time to go over those, probably on Monday. Okay, so I'm going to stay on for a minute or two and see if anybody has any questions. If not, I appreciate you attending today. Please reach out to me if you have any questions about lecture 7 or 8 or about anything else. Okay, great to see you today. Nicole, are you still on? Did you have any questions? Okay, I am signing off. This is Wednesday, the 22nd lecture on validity and reliability.